The main components of each electronic device are printed circuit boards, PCBs, with mounted electronic assemblies. Such printed circuit boards can be found everywhere, in computers, cars, phones, and household appliances. The TELE Radio Research Institute is a leader of innovation in printed circuit boards manufacturing. The Institute's production plants produce both simple and more complicated multi-layer PCBs, as well as rigid flex ones, or an advanced net of connections between circuit layers which can work with very high frequencies. The TELE Radio Research Institute has been improving the production technology of such printed circuit boards for 30 years now. The solutions created in Warsaw now work in a variety of devices worldwide. They help in outer space exploration and in high-tech antennas installed in the International Space Station ARIS. The Institute's production plants produce multi-layer PCBs with integrated copper radiators for high-output controllers, specialized and rigid flex PCBs for the military and medical sectors, as well as 1mm thick 10-layer PCBs. All printed circuit boards produced at the Institute are subject to strict optic and electronic inspection, using specialized equipment. Highly experienced process engineers with ISO certificates is a guarantee of the error-free execution of the most complex orders. Scientists at the Institute developed technology for production of printed circuit boards, as well as the assembly process for encrypting mobile phones, which is the only device both designed and produced in Poland. Its design is unique, also by international standards. The TELE Radio Research Institute has unique equipment for testing state-of-the-art PCBs, not available anywhere else in Poland. Laser and numeric drills, 200,000 RPM spindle, allow the execution of holes from 25 micrometers for laser and 100 for mechanical techniques. The metallization line, fitted with switched mode power supplies, SMPS, and special baths with high throwing power, allows the realization of galvanic processes necessary to ensure metallization of high aspect ratio interlayer connections. A refill bath for blind holes is used to research via in-pad technology. Specialized printing down frames using collimated light allow accurate imaging of a fine-line circuit mosaic. The vacuum press allows the control of the parameters of joining multi-layer boards and work on the sequential build-up SBU technology of layers. Such devices are indispensable for provision of comprehensive services for external customers. The Institute regularly hosts visits by representatives of high schools interested in the production process of modern printed circuit boards. In addition to research divisions, the Institute also has an Electronic Mounting Innovation Center. A modern lead-free mounting process compliant with the ROHS directive has been developed there. This way, integrated circuits in BGA packages, miniature CSP components, not enclosed semiconductor flip chip structures, and passive components with sizes starting from 01005 can be mounted on PCBs. The assembly process of electronic components starts with the selective printing of soldering paste on the surface of printed circuit boards. In addition to traditional screen printing, using stencils, engineers from the Institute also use a pressure printing technique. This technique allows the management of needs of customers seeking unconventional solutions, such as the automated assembly process of through-hole components, also called through-hole reflow (THR) technology, or filling of blind hole spaces in the production process of multi-layer printed circuit boards. After the screen printing process, the electronic components are assembled on the PCB's surface, using an automatic precision 2-module assembly line. Such armed boards are then moved to a multi-zone reflow oven for the melting down of solder paste and creation of solder joints. The Electronic Mounting Innovation Center is prepared to assembly not only prototype series, but also medium and large series. The productivity of equipment used here is up to 20,000 components per hour, keeping the accuracy of electronic components positioning at a level reaching hundredths of a millimeter. The expertise and long-term experience of scientists and specialists from the TELE Radio Research Institute allow projects applying the latest achievements in science and engineering.